Hi everyone. Uh, this is ML system design harmful content detection system. So Jaimit, who has been leading the ML study circle for the EOTF, Emerging Open Tech Forum or Foundation. So this will be his use case number 4, and with the introduction, it is to be 5. So this will be the fifth one. You will find it as 000123 4 listed in the what you call the Open Tech Forum 1140, which is the YouTube videos, location where we preserve it. So with that, welcome to Jamit and all the participants here. Uh, Thank you for joining, especially what you call all the participants. And let's hand over to Jamit Saba. Jamit, go ahead. It's yours to continue presenting.
Sure. And thanks a lot, first of all, Prakash sir, for the introduction. So, hello everyone. My name is Jamit Wasawa, and I've been discussing the different use cases in the ML system design. We started with the ML system design 00. This is our fifth or sixth presentation. This time's where we discussed different use cases. So this time the use case is harmful content detection system. So basically, we are going to discuss the system for whenever social media platforms have harmful content which are inappropriate according to their guidelines, they remove that post and report it to the user for the removal of the post, as well as taking care of that whether the user will be uh, following the community guidelines for the platform in future as well. So in the image you can see that we are having different posts, and the harmful content detection system is detecting the post which contains harm. So you can see that there are three posts which are processed by the harmful content detection system, and two of them are being harmful, whereas one is being benign. So when we discuss this whole ML system design, there are such certain assumptions that we are making, as well as there are certain constraints that we already have. The so there are so in assumptions, I will say the assumptions and constraints. I will say that there are harmful contents as well as how bad actors or bad acts. So the harmful contents are posts that contain violence, nudity, hate speech, self-harm, etc. And bad act or actors are fake accounts, spam, phishing, organized unethical activities, and etc. So in this use case, we will be focusing on harmful contents and not bad act or bad actors. Also, we are assuming that the platform is receiving 500 million posts per day. So 500 million posts per day is actually the post that Twitter gets that per day. And for for detecting, just in case, let's say that uh, we are we are having human annotators for uh, for annotating the post, whether it is harmful or not, or in which class of harm does that belongs to. So for a limited post of 10,000 posts per day, human annotations is available. First, so discussing the model system design further, which is clarifying the requirements, which is harmful content detection system detects which detects harmful post and demotes or deletes the post and informs the user for the post deletion. Post can be image, videos, text, or any combination of these, and the post can be multiple languages. And users can report or notify harmful posts. The now framing the problem as an ML task. Just a second. So after we have clarified the requirements, we will be framing the problem as an ML task, which is defining ML objective, which is to accurately detect harmful posts and remove or demote them, and leading to a safer platform. So specifying the system's input and output, which so the system of the system's input is a post, and there are various aspects to the post. So the post can contain image, the post can contain text, the post can contain video, and or any of those combinations. So this gives rise to the potential multimodality of the post. So the post can be heterogeneous and can potentially be multimodal. And to approach this multimodal characteristic of the post, we have two common modalities, which are late fusion and which is late fusion and early fusion. Discussing the late fusion, the ML model process different modalities independently and combine their prediction to make a final prediction. So going in the diagram, going from bottom to up, we have post as an input, and the various aspect of the post, which is image aspect, the text aspect, the author aspect, or the visual video aspect of the post. Each of the post will be treated with their own respective models, and the output of those models will be fused together to give us the harmful probability. So the pros and cons of the late fusion is the advantage of the late fusion being is that we can train, evaluate, and improve each model independently. And the disadvantage is that each model needs separate training data, which can be time consuming as well as expensive. And the combination of modalities is harmful even if in isolation they are benign. So let's say, so the example of it is me, which is an image containing text. So the text independently is benign. The image independently is benign, but the combination of those can prove prove out to be harmful. So that is something that the late fusion is not able to capture the contextual aspect of it. Discussing further the early fusion, the modalities are combined first and then the prediction are made. So you can see in the image going from bottom to up, we have the post as an input. It's a different aspect of the post, and they all of them are fused together and given to the model as an input. And the model will be giving us the calculated harmful probability whether the post is harmful or not. So the the two common modalities are early fusion, pros and cons. Two common Discussing the two common modalities of where we are discussing early fusion. The pros and cons of it are two major advantages to early fusion are same training data for the whole model, as the model is taking all of the aspect of the post is treated with by the same model, and capturing the whole modality. That is, if combination of modalities are harmful, the model can potentially capture in the unified feature vector, which is something the late fusion was not able to do. So disadvantage to early fusion is learning the task is difficult for the model due to the complexities involved. In absence of sufficient data is challenging, and the model to for the model to learn complex relationships and make good predictions. So we'll be using early fusion. The the reason to that being, first, it allows us to capture the posts that are harmful overall, despite each modality being benign individually. And additionally, 500 million posts are being published every day. So the model had enough data to learn the task. Choosing the right ML category, we'll be discussing four categories, which are single binary classifier, one binary classifier per harmful post, multi-class label classifier, and multi-task classifier. Single binary classifier, the model takes in fused features as input and predicts the probability of the post being harmful. Since the output is binary, it is called binary classifier. So basically, the reason to name it binary is because we are detecting whether the post is harmful or not. So it's a 1-0 thing. So that is the reason for a binary classifier. So in the image, you can see in the diagram, you can see that we have fused features of the post, which will be given to the model, and the model will be giving us the harmful probability of the post. So the whole post is represented by the fused features. Limitations of a single binary classifier is we get the output of the post being harmful, but do not know which class of harm does that post belongs to. So it's basically only letting us know whether the post is harmful, but we are not able to know which class of harm does that post belongs to. Two issues arise due to this are we cannot say user why the post was removed, and if the model is not performing well in some classes, it is not possible to know and improve the model on underperforming classes. So let's say the post contains image, text, and video aspect of uh, video. So each and every aspect of it is has to be treated. But let's say the model is not able to perform well in video aspect, or uh, knowing uh, or detecting the harm in the video, then will not be able to know. And so that that is what the statement means. Binary classifier per harmful class. Each model predicts the probability of the post being harmful. So in the diagram, you can see that fused features of the post is given to each and every model, and each and every model will be calculating the probability of each class of harm. So each model takes fused features as input and predicts the probability of the post being classified as a harmful class. The advantage to it is we can explain to user why a post was taken down, and also evaluate and improve the models independently. Disadvantage to it being, as we have multiple models, we have to train them and maintain them separately, which is time consuming as well as expensive. So multi-label classifier, the data point can belong to belong of arbitrary number of classes. So a single model is used as a multi-model classifier. The input to it being fused feature, and the output is the probability of harmful class. So one model will be giving us each and every probability of the harmful class or the class of harm that we have. So the advantage to it is training and maintaining the model is less costly, and disadvantage to it is predicting the probabilities of each harmful class using a shared model isn't ideal, as input features may need to be transformed differently. So, so in multi-level classifier, the input features should be transformed in a different manner. So that is the reason, that is one of the disadvantages to it. Moving further with that multitask classifier, the multi-class in multitask classifier, discuss about multi-class learning. So multi-class learning is a process in which model learns multiple tasks simultaneously, which allows the model to learn similarities between tasks. We avoid doing unnecessary computations when a certain input transformation is beneficial for multiple tasks. We are treating different classes as different tasks and use this model to learn each task. So you can see in the diagram below, which goes from bottom to up direction, we have fused features which are given to the shared layers. These shared layers are transforming the fused features in transformed features, and these transform features are given to the task specific layers, where each and every class of harm that we have has been listed, and each and every class of harm will be giving us the probability of the post, how much uh, how much is it. So so you can see that there are two main layers in this diagram, which are shared layers and the task specific layers, and we'll be discussing both of them. So, discussing while discussing the multitask classifier, we have shared layers. So, in shared layers, what shared layers do is they transform input features into new ones, which are used to make predictions for each of harmful classes. So, input features themselves are made in such a way that will be helping us to predict each of the class of harm that we have. Moving further with the task specific layers, the task specific layers are independent ML layers, also known as classification heads, which transforms the features in a way which are optimal in predicting the classes. So in the diagram, you can see that we have transform features which are generated by the shared layers from input features. And these transform features are given to the task specific layers, which are giving us the probability of the class of harm. The advantage to the multitask classifier is using a single model helps to train and maintain it. So we are basically using a one single model to treat the class of harm, to predict the class of harm. The shared layer transforms the features in such a way that is beneficial for each task, which reduces the redundancy to compute on each feature for each model. And training data for each task contributes to training of other tasks as well. And for these advantages, we'll be using multitask classifier. So this is the overall view of the multitask classifier. Uh, Going from bottom to top, we have uh, we have post as an input, and various aspect of the post being image, text, author information, and video if video is present, and fusing those information together and creating a fused feature. Now these fused feature are given to the are passed on to the shared layers as an input, which will be transforming the fused features into transformed features. And these transformed features will be used by the task specific layers to predict the probability of the class of harm and also the overall harmful probability of the post. Now, discussing the data preparation for training the model, we have data engineering. So basically, we are discussing about the data that we have in hand. So we have user data, we have the post data, and if the post contains any links, we will have links to it, and the user post interaction data, where we have user ID, the post ID. If the if the post contains any interaction value, which are comments or reports, then those interaction values will be taken. And if it contains a report, then the which class of harm does that report lie under is take is or interaction value and the timestamp to it. Discussing further in the data preparation, we have feature engineering, where we will be using different features which are of our use to train the model. So first is that feature engineering is basically the contents of the post. What does the post contain? So the post can contain textual data, image or video or both, the author of the post, the user reaction to the post, and contextual information. So first, discussing the textual content. To use textual content of the post to predict whether the post is harmful or not. The way we process the textual content are in two ways. The first is text pre-processing, where we have normalization, tokenization, etc. Normalization is basically using if there is a sentence, then we normalize the sentence by uh, making all the letters in lowercase, removing the punctuations and all, and further passing it on to the tokenization, where each of the normalized sentence, the words that are present in the sentence are treated as individual tokens, which are passed on to for the vectorization. In vectorization is to convert the text into meaningful vectors, which is so vectorization has two methods, which is first is a statistical method, which contains bag of words and term frequency inverse document frequency. But the problem with a statistical method is that they do not contain any contextual information within them. The way they form the vectors, they do not contain any contextual information. In ML based methods, we have transformers. So transform based architectures are used. So here we will be using and going further with BERT, which is bidirectional encoder representations from transformers. And two main points one should keep in mind while working with BERT is it is slow and is not ideal for real-time prediction, and it was only trained on English. So for BERT being only trained on English, a variant of BERT, which is Digital M BERT, should be used, which is trained on 104 different languages. And the way BERT or any variant of the BERT will work is basically that if there is one sentence in two different languages, the encoding that will be produced by them will be very similar, as they mean similar and they have a similar meaning. or same meaning. So now the image or video, how the image or video of the post will be treated. So to know the contents of the image or video, which uses pre-processing, the pre-processing them, which is decoding, resizing, and normalizing the data, and feature extraction, which is to convert the unstructured data into feature vectors. Feature extraction technique for image, we have LEPS visual encoder or SIM-CLR, which is simple framework for contrastive learning of representation. And for feature extraction of video, we have video MOCO, which is video momentum contrast. Discussing further with feature engineering is user reactions to the post. So the likes, shares, and comments, which helps us determine if post is harmful, especially when the post is ambiguous. So number of likes, comments, shares, and reports. These values are used to speed up convergence during training process. So convergence in ML is basically when a model reaches convergence, it achieves a state during training in which loss settles within an error range around the final value. So loss is basically the difference between the ground truth value or the real value and the prediction that was made by the model. So when loss is settled within a specific range, and training the model further will not improve the model, uh, is called convergence. So moving further with comments of the uh, in user post reactions, the comments can help us identify harmful content, which is using comments in feature engineering, which is using the pre-trained model to convert comments into numerical representations for each comment, and also aggregating the embeddings to create a final embedding. So each of the comments that are in the post will be converted into their comment uh, into their respective embeddings, and each of those embeddings further will be aggregated together to create one final embedding of the post comments of the post. So this is uh, what we are trying to discuss. Starting from the bottom right, where we have content. So the content is basically the post that the user has posted, which contains a text, an image, and a video. And each of the text, image, and video are pre-processed, and using a pre-trained model for each for them, the their own respective embeddings are created. And now moving to the left side of the image below, you can see reactions. So reactions are basically uh, comments and number of reports, likes, comments, and shares. So now number of reports, likes, comments, and shares, they are numerical value and numerical representation to the reaction of the post. But they don't give us that much of a depth into understanding the harm content within the post. But the comments in the of the post will give us that. So the comments are treated differently, and the comments, after pre-processing them, pre-trained models will be generating the embeddings for each of the comments that are present for the post, and aggregate them and to create one final embedding of all the comments that are present on the post. And all of these embeddings are concatenated in the final concatenated features. Now we have authors features, where authors past interaction to determine the post is harmful or not. The author's violation history, which is number of violations, is a numerical value of number of times user violated the guidelines in the past. Total user reports, which a numerical value of number of times user reported author's post and profane words rate. Numerical value of number of times in the past the user's post or comments contain profane words. A predefined list is used to determine whether a word is profane. An author's demograph, which is age of the author. A user's age is one of the most important predictive features. The gender of the author, which represents gender of the user. One hot encoding is used to represent gender. City and country. For both the city and country take many distinct values to represent features. We use a embedding layer to convert city and country into feature vectors. And one hot encoding is should not be used here for city and country as the vectors generated are very big. Most of them will contain zeros and they will be very sparse. The account information, we have number of followers and followings. Account age, numerical representation of the age of the author's account. This is predictive feature as accounts with a lower age are more likely to be spam or to violate integrity. Contextual information, time of day, the time of day when the author made a post. We bucketize into multiple categories as morning, noon, afternoon, evening, or night. The other one is device. The device the author uses, example, mobile phone or desktop. And for both the contextual, both of the categories of the or both of the points of the contextual information, which is time of day and device, we will use a one hot encoding. So the so this is the overview of what we are doing or discussing. Uh, Going from bottom to up, we have post as an input. The various aspects of the post being image, video, text, comments, and the author of the post. Each of those features are converted into their respective embeddings by their own own pre-trained models, and their embeddings are further used for concatenation. Now, coming towards model development, we'll use a neural network for multitask learning. To work with neural network, we have to determine neural networks architecture. So neural networks basically contain an input layer, the middle layers going towards the output layer. So neural networks architecture and optimal hyperparameters, which are hidden layers, the activation functions. So activation functions basically help us to uh, fire up the neurons that are present in the hidden layers. So the value of neurons can be basically from minus infinity to plus infinity anywhere, but we have to fire them up in a particular order. So that is what the activation functions helps us to do. And to also we activation functions helps us uh, to fire up the neurons that we need and not to fire up every neuron that is present. And then there is a learning rate. Learning rate is basically the rate at which the model is learning. To choose optimal hyperparameters, Hyperparameter tuning is used, which is a process of finding best parameters for getting the best performance from the model. This involves three steps: training a model for each combination of hyperparameter values, evaluating each model, and then selecting the hyperparameter that leads to best model. In model development, discussing the model training. So for training the model, we have to construct the data set which will be used to train the model. So what so what are the aspects we can use? We have to consider while constructing the data set. So the model's input are features and outputs labels that model is expected to predict. There are two ways to construct the data set for input. One is hand labeling, where a human contractors are labeling manually, and the other one, but the problem with hand labeling is it will create a precise data set, but will be very time consuming as well as expensive. And the other one is a natural labeling. So natural labeling is we use user reports to label posts automatically. The natural labeling is will create the data set very fast, but it will contain a lot of noise. So so for evaluation data set, we will use hand labeling to prioritize the accuracy of the labels, and for training data set, we will use natural labeling to prioritize the labeling speed. So you can see that so you can see that in the diagram below we have a post, and passing the post from the feature preparation, we have its features lined up, and each of and and we have the label for the post, which contains the a class of harm of violence as well as the self harm. Discussing further the choosing the loss function. So loss function is basically the difference between the output and the ground truth value, or the output that we want, and the output that the machine learning model is giving us. So training a multitask neural network is similar to the neural network, which consists of forward propagation, loss function, and backward propagation. So forward propagation, as I mentioned before, that the neural network consists of input layer going towards the hidden layers, and hidden layers going towards the output layer. Now, forward propagation means going from input layer towards the output layer, and backward propagation means going from output layer towards the input layer. Now, backward propagation with a loss function helps us to adjust the parameters that we have been using for the data set to process the data. Now, when we use backward propagation, we adjust some of the values for the future iterations to be for the model to be used on those parameters. In multitask training, each task is assigned a loss function based on ML category. In our case, task is classified as binary classification. So our loss function is standard binary classification loss, such as cross entropy for each task. And for overall loss function is computed by combining task specific losses. So that is something that you can see in the image below. Similar to the previous images, the going from bottom to up, we have the fused features. The multitask neural network is calculating the probability of each of class of harm, and the loss, the calculating the loss, and for the overall performance of the model. Sorry, for the overall loss function is computed by combining the losses of the each of the specific task specific losses. And also, when learning speed varies between models, one model can become dominant on others. So, to address this, and there are two common techniques, which are gradient blending and focal loss. So now it's time to evaluate the model, as we have already talked about the constructing the data set for the model and training the model. So now it's time to evaluate the model. So first of all, we'll be starting with the confusion matrix. So the diagram in the pink is somewhat is what we call a confusion matrix, and you can see there are various metrics which are listed with we'll be using precision and sensitivity. So precision is below the false positive, and sensitivity is beside the false negative. Sensitivity is also called as recall. So mapping the precision on y-axis and recall on x-axis, as you can see in the image on the bottom right, we get a curve, and both of them will be mapped within the range of 0 to 1. So we'll be getting a curve, and the area which lies under the curve, which is AUC, area under curve, is the performance of the model. Now now there is also a metric called F1 score. So F1 score takes both the precision as well as recall, which so F1 score is used to calculate model's accuracy on how many times a model made a correct prediction across the entire data set. Also, also here you can see that the precision is taking into consideration the false positive values, and in the sensitivity you can see that the sensitivity or recall is also taking into consideration the false negative values. So what we discussed further were the points for the offline evaluation. So the metrics like precision, recall, and F1 scores are used. So we use the PR curve, which is precision recall curve. The PR curve is obtained by plotting precision at different probability thresholds ranging from 0 to 1. And PR AOC, which is precision recall curve, and calculating the area under the curve, is calculated to area beneath the PR curve. Receiver operating characteristic curve is similar to PR curve, shows the trade-off between the true positive rate and false positive rate. And AOC for ROC is calculated. And by the way, if we are plotting the PR curve, if the value of precision is high, the recall is going to be low. And if the recall value is high, the precision is going to be low. So for offline evaluation of our model, we will be using both the PR curve as well as the ROC curve. Discussing the offline metric, online metric, sorry, discussing the online metric. Uh, First one is prevalence. The prevalence is equals to the number of harmful posts we didn't prevent divided by the total number of posts on the platform. The issue with prevalence is that it treats a post with 100K views same as 10 views, a post with 10 views, whereas post with 100K views is more harmful. Harmful impressions, unlike prevalence, this metric captures how many users got affected by the post during harmful impressions. In valid appeals, we have the formula for it is number of reversed appeals divided by the number of harmful posts detected by the system. The percentage of posts that were deemed harmful by the system but were reversed. In proactive, we have proactive rate equals to number of harmful posts detected by the system divided by the number of harmful posts detected by the system plus reported by the users as well. So the percentage of harmful posts deleted by the system before the users report it. And fifth, we have user report per harmful class, which gives us the measure, which measures the system's performance by looking into user reports for each harmful class. So this is the overall workflow of the system. So we have the user, which will be using the application, and the and in the application, depending on the user's post being harmful or not. So if it is harmful, then harmful content detection service will be detecting the post with low confidence and detecting the post with high confidence as well, which will be further given to the detection of post with high confidence will be dealt with violation enforcement services, and the detection of posts with low confidence will be dealt with demoting services, which will be further used for training purposes and will be stored in a separate database. So the harmful content detection service, this service predicts the probability of harm, and some types of harm should be dealt with immediately due to the sensitivity. So there are a certain kind of harmful content which contains very offensive or sensitive usage in the post, which should be dealt with in immediate action. So that is what we are trying to say. The sensitivity is so in such that it should be dealt or removed from the platform immediately. Violating enforcement service, it removes the post if a harmful content detection service predicts the harm with high confidence, also notifying the user why the post was removed. Further is a demoting service. When the harmful content detection service predicts a post of low harm confidence, the post is demoted. Demoted means the post's reach is restricted from not allowing it to spread further. So the post is demoted to decrease the chance of spreading and then sent to humans for manual assessment and are labeled with predefined classes. These posts are stored for future training iterations to improve the performance of the model. So to summarize the whole use case that we have discussed for the harmful content detection system, we first started with clarifying the requirement, sorry, where we decided to where we the requirements were to design a harmful content detection system and not to deal with bad actors or something, but the post be, containing any harmful content or not. In the framing as a machine learning task, we discussed about defining the ML objective, where the post is an input and the output is the harmful probability calculated by the machine learning model. Specifying the input and output of the system, we discussed two modalities depending on as we or the post contains uh, post was a multi-model, so that is the reason we discussed for two common modality approach, which were late fusion and early fusion, and we decided to go with early fusion. In the ML category, we discussed four categories, which were a single binary classifier, one binary classifier per harmful class, the multi-label classifier, the multitask classifier, in which we went with a multitask classifier and further discussed two of its components, which were shared layers and task specific layers. In the data preparation, we discussed the data that we are dealing with and or the data that we have in hand. So in data engineering, we discussed about the user data, the post data, and the user's interaction with the post. In the feature engineering, we discussed the what kind of information does the post can contain. So we started with textual content, and we discussed about the pre-processing of the textual and vectorization of it, and the image or video, and we discussed about the pre-processing as well as the feature extraction of them. For image, we mentioned about clip as well as SimCLR for feature extraction, and for video, we mentioned video MOCO, which is video momentum contrast for videos feature extraction. The user reaction to the post, the author features, and the contextual information. In the model development, we discussed about the model selection, which is multitask neural network, the and the model training. We discussed about the constructing two ways of constructing the data set, which was hand labeling and natural labeling. And for evaluation data set, we went with hand labeling, and in natural labeling, we for test data set, we went with natural labeling. Then we further discussed about the loss function and chose to go with a cross entropy. Coming to the evaluation of the ML model, we discussed about the offline metrics, which are PR curve, ROC curve, the PR AOC, which is uh, a calculation of area under the curve of PR curve, and calculation of area under the curve of ROC. In the online metrics, we discussed about the prevalence, harmful impressions, valid appeals, proactive rate, the user reports per harmful blast. And in in the end, we discussed about the serving, where serving was a harmful content detection service, violation enforcement service, and demoting service. So basically, harmful content detection service was detecting the whether the content was harmful or not. If the content was harmful and the system was highly confident on it, the it was passed to the violation enforcement services, and the user was reported by notified by the post of that user was removed. And the demoting services were the post where the system was less confident and were given further for the human manual assessment. And those posts were also separately stored together for the future training purposes for improved performance of the model. Now the system that we are now the system that we have been discussing had a lot of assumptions made, and also a lot of and it's also discussed under different types of constraints. So there are for so even if the system is made, you can further add some of the components of it, which can further so you can further add different components to it, which further improves the model or working of the model or changes the way the model works. So the additional talking points for the model is you can add a handle biases introduced by the human labeling, how to detect authentic and fake accounts, and how to select post sample for human reviews, how to make harmful content detection system efficient so we can deploy it on device. So the system that we have been discussing is cloud based, but we are discussing here about what if we can do it an on device for the harmful content detection system, and how to deal with borderline contents, that is the type of content that are not prohibited by the guidelines but comes close to red lines drawn by those policies. So this is the whole use case for the harmful content detection system. And thanks a lot for listening. Thank you.
Hey, thanks, Jimmy. And I think we had questions from few of them. We answered offline on the chat. So I think we can close here. And next week, we look forward to YouTube video on recommendation systems. So thanks a lot. And with that, I will stop the recording. Okay.